Okay, number 9, write an equation of the quadratic function given on the graph. Use vertex form. So that would be this graph right here. So we have to find values for A, H, and K. Well, HK is the easiest, okay? Right there is HK. It's like an XY, but don't label it XY. You're backwards 3, and you're up 2, okay? Backwards 3, negative 3, up 2. So your H is negative 3, your K is 2. If it's minus negative, make it plus plus. So now we just got to find the A, but that can be a chore. Now you're going to write that equation with the 3 and the 2. X plus 3 to the second plus 2. I'm just writing that so it looks cleaner. Now I put my HK point over here, okay? Or actually, never mind. Now I got to find an XY point that I can use. I'm not going to put it in there, but I'm going to put it in here so it allows me to find A. So I'll pick that one. That's backward 1, so negative 1, down 1, negative 1. Okay, so negative 1, negative 1. So put those into the equation. Y is negative 1, and X would be negative 1. Now here's what you do. You write your A. Okay, you put a times in the front, and then put that plus 2 behind. Now you got to find what this whole parentheses equals to find what your A is multiplied by. Because it's A times that, but I want the A to come second. So negative 1 plus 3 to the second. Well, that's 2. 2 raised to the second is 4. So place a 4. A is multiplied by 4. Okay, so you got to take out the plus 2. So it's negative 3 equals 4 times A, and you divide by 4. That's a decimal, negative 3/4 is your A. Now come back up here and write the equation so it looks nice. Y equals negative 3/4, quantity X plus 3 to the second plus 2. Again, any equation I write's got to have Y and X in it. So again, mark your HK, okay? Then write your A, and you got to have a second XY point. That's either that one or this one. It doesn't matter. You get the same thing. Okay. Then you substitute those in for X and Y. So negative 1 equals something times A plus 2. To find the something, you simplify the parentheses. Then you solve it. That goes right there. Okay, story problem time. A shop sold 50 skateboards last week. They're selling them for $70 a piece. The store thinks that each time they decrease the price by $1, one more skateboard will be sold. How many times should the store change the price to maximize their revenue, and what will that revenue be? So I'm finding maximum revenue. Anytime I'm finding a maximum, it's a giant parabola in the center. Okay. So there's an XY, and you got to know the formula to find the max. It ain't the quadratic formula. It's opposite of B divided. It's a quadratic formula without the square root. Okay. It's like half of the quadratic formula because you're halfway down. That's a way to think of that. Okay, Y replace X. Okay, so this is revenue. How do you write an equation for revenue? Well, revenue is taking the money I'm charging times the items I sell. So find a money amount. The money amounts go together, so $70 and $1. So you start at 70, and then you're decreasing it by $1. So that's minus $1 X, because you're going down by 1 repeatedly. Now the items, if that's minus, then the items increase. That's going to be 50 plus 1X. Now, we're going to have that be Y. So, by the way, X represents the number of price changes, and then Y represents the revenue. Okay, you got to get an A and a B. You can't have it in factored form like this. So you got to take 70 times 50. the FOIL method, because we have a plus, negative, plus there, and a plus there. So you take 70 times 50, 70 times 1x, then negative 1x times 50, and negative 1x times positive 1x. So that's 3,500. That's x with 70. That's x with negative 50. That's x to the second with negative 1. Okay, so line up, simplify it, because two of those can go together. So negative 1 is your x squared. That's your a. 70 and negative 50 add to 20. That's your b. And 3,500. Okay, so opposite of b, that'd be negative 20, and then 2 times negative 1 is negative 2. Then divide, you get 10. 10 price changes. Okay, so what's the revenue for that? Well, you're going to replace your x's with 10. Punch that in. Okay. Okay, 3,600. Fill out your coordinate and the maximum revenue. 10 price changes gives me my maximum revenue of $3,600. Okay, then 11A. 11, last problem has an A and a B. We're going to do the A on one page, the B on another. So 11A. A missile is launched into the air with an initial vertical velocity of 800 feet per second from an initial height of 200 feet above the ground. Calculate the missile's maximum height, then calculate at what time the missile will be 500 feet above the ground. Okay, so seconds, or no, we're finding the maximum height here. So like the last problem, you want to draw your big parabola. Big parabola. I got to find the x and the y at that point. Opposite of b divided by 2 times a. And the y is simply substituting for x in the equation. This whatever I find here. Okay, this isn't revenue, this is gravity. So I go line up my blanks right away because I don't need the parentheses. So gravity goes here, negative 16. Velocity here, that's 800. Okay, then 200 feet, that's your starting height. So opposite of B, negative 800. 2 times negative 16, negative 32. Then I divide 25 seconds, okay? Then I substitute 25 in for the x. Okay, 10,200. And that's your feet. Okay, maximum height's 10,200 feet. And you get there in 25 seconds. Okay, and 11B. A missile is launched into the air with an initial vertical velocity of 800 feet per second from an initial height of the same thing, but now you're doing something different. Calculate at what time the missile will be 500 feet above the ground, so you're finding the seconds. Okay, so I'm not finding the max height, so I do a little deeper analysis. Feet and seconds. Seconds is x, feet is y. So the feet per second is 800 still. We're not making the table because it's a quadratic equation. It goes up and comes down. But I'm not finding the maximum anymore, so I mark where it starts, which is 200 feet. And then on the other side, I mark what the question's asking me for, 500 feet. Okay? So my job is to find how many seconds go with that. So it's the same equation as before. I I just do something different with it. So that's your gravity, that's your velocity 800. Your starting height, start height, it's going to be 200. And then we leave y alone. Now 500 feet, okay, that goes in for y. We have to solve for x then. So 500 replaces the y. Okay, so it's a quadratic equation. Okay, so you got A, B, C, and double C's. Okay, so you got to have it lined up all on one side. So minus 500, minus 500. So you got negative 16x squared plus 800x plus 200 equals 0. Okay. All right, so that's A, that's B, that's C now. So let's apply the discriminant. I really don't care to factor that if it's prime. So B, 800. A, negative 16. C is, wait a second, I screwed that up. 200 minus 500 is negative 300. Okay, that's your C. Okay, punch that in. Okay, 787.91, that's prime then. So I'm going to put that, because this is a story problem, so I don't do the 2 square roots, okay? I just approximate it. So in this square root, I will not be simplifying it, I will just be approximating its value, which is how a story problem should be done. Okay, so opposite of B, we know that's negative 800. 2 times A, it's going to be 2 times negative 16, that's going to give me negative 32. And then that, I'm not going to simplify it, I'm just going to put my 787.91 from the other side, okay? Because it is a story problem, so yeah, we don't really care to have a square root in the final answer, okay? So 0.38 49.62. Now both those are viable solutions, so I expect to see both of those because they're both positives. The reason you got 2 solutions because it hits 500 feet on the way up, which is what the 0.38 is for, but then on the way back down it's going to go to 500, then a lot of time has elapsed, 49.62 seconds.